My name is Jana Young, and
I'm Corey Bobby. Welcome to AP Statistics.
we are going to be your teachers for this course. I'm actually your teacher of record, and Mr. Bobby is your bonus teacher. And we are going to walk you through AP Statistics. So we thought we would begin just with a short introduction of ourselves. Again, my name is Jana Young, and I am and was a teacher, even at Lakeside, both of us were, and am now a curriculum facilitator at Eastham High School in Little Rock. I have a daughter who is going to be second year student at UCA. I have a wonderful husband. I sometimes run, and I am slightly obsessed with my dogs.
Yes, she is. And my name's Corey Bobby, and I also taught at Lakeside, among other places. But Miss Young and I used to teach at Lakeside in 2010 to 2015 or something like that. So if you have an older brother or sister at that time, they may remember us. I have a couple obsessions, and one of them is actually on display right here. I'm all about the pink. We are recording this on Wednesdays, so on Wednesdays we wear pink. And you'll understand the references to flamingos and statistics maybe a little later. I also have a attraction to shoes. I like sparkly shoes, and yes, these have bottoms, so I'll make sure that when we actually get together, you'll sometimes see colorful shoes. I drive a motorcycle that is gorgeous, but maybe you'll have to wait to see that. And I also am slightly into, as I have a family of dogs. I don't have any children of my own. My dogs are a form of my own kids.
And just so y'all are clear, normally he says my wife is gorgeous, but this time he told you his bike was gorgeous. So
Oh, yeah, I am married
those
to
are his priorities at this moment. Okay. A little kind of quickly about this course. You're going to have 9 modules spread out over the whole school year. We'll actually finish 5 of the 9 modules the first semester, then we'll do 4 modules second semester, and then a review before the AP exam. Each module will begin with a face-to-face lab that is required. And those labs are actually worth 100 points, and that's an easy 100 points to get. You'll just fill out the lab manual. Those labs will be in the evenings from 6 to 7:30, and your syllabus will include the dates for that. Generally, they will fall on Tuesday, barring unforeseen circumstances.
You have the right, if there's an emergency situation, we'll have to reschedule. But
right. You're going to get a module checklist for each module outlining the videos and assessments and assignments that are required. All of that will be found on Google Classroom or whatever learning management system we land on. And then also for each module, we will give you a recommended schedule. That doesn't mean you have to follow that schedule exactly. It's just our recommendation. The only thing you'll have to do is you will have to have everything turned in by that final module due date.
if you procrastinate, you're not going to be a happy camper. So we suggest you may not have to follow it exactly, but you might not want to get 2 weeks behind.
Right. Your assignments will often come from Khan Academy because they align with College Board. In fact, the AP writers also write questions for Khan Academy, so they're very well aligned. And then sometimes you'll get those assignments on Google Doc, just depending on what we're doing. And all the points for the assignments will vary depending on the assignment. Your quizzes will come in many forms. Sometimes they'll be on AP Classroom. Sometimes they'll be in a Google Doc. Sometimes I'll maybe even send you something on Google Classroom. Even sometimes we might be working on projects. We're going to do a lot of different stuff in this class. So just kind of be paying attention to your module checklist. It'll be pretty well laid out. Each module will end with some kind of exam. That doesn't mean a paper and pencil exam always. It could mean a project. It could mean a lot of things. But for sure, each module will end with a multiple choice exam on AP Classroom. The combination of the free response part of the exam and the multiple choice part of the exam will always combine to make 100 points. You will begin and end each module with 100 points, 100 for the face-to-face lab and 100 for the exam for that module with a bunch of stuff in between.
It'll all be lined out in the schedule, each module schedule we give.
Right. We will also be available to you in the evenings, Monday through Thursday via Zoom. Sometimes you might get both of us, sometimes just one of us, but we'll always be around to answer questions for you if you're needing a little bit of help. So
Yep.
I hope that's clear as mud. You need to add anything here, Mr. Bobby?
No, I think so. You can, and you'll be always able to reach us through Remind or email as well outside of the office hours. But we do both have regular jobs. I do want to remind you the reason we're doing a lot of things in the evening is because we both do have regular jobs. So if you are working at 1 p.m., don't expect an immediate answer because we were working. And if you ask us a question at 1 a.m., please, you certainly aren't going to get an answer.
Yeah, 1 a.m. means you're not going to get a response until the following evening. Yeah, we will respond generally within 24 hours, barring, again, unforeseen circumstances. But that is very important. We will only be responding to you in the evenings. Okay.
All right, let's get started. Let's do some stats.
A little bit of stats here. So I'm going to try to move us here. Here we go. So the first part of this, section 1.1, super easy, introducing statistics. What can we learn from data? So I did a thing. I Googled COVID
Googles
graphs. I hit the Googles when I just typed in COVID graphs. And I wanted you guys to see, and then I went to images, you know what I'm talking about?
Yeah.
And then I just drug some over. And look at all the variations of graphs that you can find about this one topic. And the flamingos are also overwhelmed.
They're overwhelmed. That's too much. Too much.
And every single one of these graphs are graphs that you've learned in a previous course. And so one of the things that we want to be able to do is just, understand the information that we're given to us. And then we want to be able to identify that there's a problem and what we can do to help solve that problem, right? So again, just a bunch of
are very relevant and problem that I'm concerned about.
Right. And so each one of these graphs is trying to answer a question that's being asked in some way. So and some of it's crazy, like this pie chart over here is a survey of 410 young entrepreneurs across 18 countries in Asia Pacific in March 2020. And so what they're trying to do here is see what's happening to young entrepreneurs. That's the question. Are they being hurt? Or is there any impact at all? Whereas a lot of times what you're going to see is the flattening the curve question, where you see tons of graphs about, are we flattening the curve? So just a tremendous amount of information here about how many people died, how many people recovered, and so on and so forth. Lots of questions that are being asked, and then a graph to try to answer that question. Okay, so what is statistics? Mr. Bobby, you want to read?
I would be happy to read on your behalf. Statistics is a branch of applied mathematics dealing with data collection, organization, analysis, interpretation, and presentation. In addition to being the name of the field of study, the word statistics also refers to the numbers that are used to describe the data or relationships. Now, I need you to interpret that for me like I'm a human being, not a math person.
Okay, so applied mathematics. Wow, applied mathematics. Have we ever heard that in a high school setting before? Because so much of the mathematics that you learn in high school is not really applied mathematics. It's these little island pieces of information. I'm going to learn algebra in hopes that I can learn calculus, and I'm going to learn calculus in hopes that I can be an engineer and things like that. So this is our first sort of introduction to an applied mathematics where we might be able to actually answer a question for somebody. So when we deal with data collection, that means I might survey a group of people and collect information about them. When I organize that data, I might find a way to find a bunch of stuff that all the data has in common. When I start analyzing that data, I might find a mean about it or a mode about it. If I want to interpret that, I might try to figure out what's going on here based on my analysis. And then presentation, well, we just saw a bunch of that, right? We just saw a bunch of presentation of the data.
So basically, I can't just say whatever I want. I need to try to back it up with some kind of data or some kind of evidence is kind of maybe what you're telling me.
Yeah, a little bit of evidence, maybe not just like say things you think are true, but things you know are true based on information gathered.
Gotcha.
And then it says also that it refers to numbers that are used to describe data. So numbers that are used to describe data that you know right now might be mean, might be mode, might be median, might be range. If you remember, box and whisker plots might be interquartile range or IQR. Could be a lot of different things, and we're going to learn a lot more relationships in the numbers in this course. Okay, so why is important? I kind of hope you already know why it's important. This is one of those things that's like, okay, we know, we get it. But we want to be able to draw valid conclusions. We want to be able to say, I know I should stay home during COVID because I have all this data that says other countries have already flattened their curve and I might want to follow suit. So first of all, I might want to use statistics and its numerical evidence to draw a valid conclusion. Would you agree with that, Mr. Bobby?
Yeah, I definitely think we need to worry about that, and not just for COVID, but for a lot of other things. Anything that's medical, I would love for if when we're testing new drugs that actually does what it's supposed to do before I start taking it.
Yes, definitely. I also want to know how to avoid common pitfalls. So if I am reading an article or listening to a news story and they're talking about some statistics, I want to be able to say, ooh, their sample, where they collected the data from, maybe doesn't match their conclusions they're drawing. Maybe they took the data from a bunch of 13-year-old girls and then they're saying it's true for a bunch of old men, right? So we want to make sure that
yeah. We don't want sketchy data.
Right. We want to be careful that that the conclusions they're drawing can actually be drawn from the data they pulled and that the analysis they did is correctly done. So it's important for us as statisticians, because after this class, you're going to be able to call yourself that, to be able to see something that's being presented to you and say, that's a legitimate claim. We want to be able to use statistics to make an impact in your field. I think statistics is really interesting because it is
everybody.
Right. Everybody. It is something that's going to affect every single occupation there is. Almost at this point, no matter what you go to college to study, you're probably going to have to take some statistics class that's relevant to your field. And so we want to be able to understand a general understand a general understanding. That's not a good way to say that, is it?
We want to be able to read, interpret, and make use of statistics, even as a doctor, even as an attorney, not just as a mathematician, because attorneys make arguments in the court of law, and they should make use of statistics to back up some of their claims.
Yeah. And then I know you probably don't believe this, but sometimes there's lies, and there's damn lies, and there's statistics. And
then there's the internet.
That's right. And you need to know when something is right. You just do. You need to know. And so every single person, and the longer that I teach statistics, the more I believe that every single student should be taking some kind of statistics class before they leave high school. Even if it's not AP statistics, I believe that everybody should be taking some kind of statistics class so they can arm themselves with the knowledge to understand when somebody's using damn lies on us.
Yeah, there are people who are always going to try to sell you or make you believe something. And if you've been around, you can see it all over. And that's why I said the internet. You'll be a better consumer and better human if you can understand and shoot down somebody's argument.
Yeah. So the great thing about statistics is you have seen the model for statistics a bunch of times because it is simply the scientific method. So we will make an observation about something we wonder about or want to question or think there might be a problem. And then that will make you have a question. So for example, I bought a whole bunch of land and I can see trees. And I'm like, these trees are worth a lot of money. I might want to be a tree farmer. And so I might want to know how many trees are in my new property, but I don't want to go count them, right? And so the question is like, how many trees are on my property? And I make a hypothesis. I think there are 4 million trees on my property. Then I run an experiment some way in order to figure out how to determine the number of trees. I just made up this like tree thing right now. I don't know how to do it. I run an analysis on my experiment and draw a conclusion. There are definitely not 4 million trees on my property. So we're going to connect this circle. Now it's going to take us a while to get all the way around the circle. We're going to talk about how do we make the observation, how do we ask the question, how do we create a hypothesis. And then probably much later in the course, we're going to get to the experiment, analysis, and conclusion part of the circle. So where the beginning of this course is the first half of the circle, and the second half of the course is the second half of this circle. But before it's all said and done, we want to be able to complete the entire scientific method on a set of data to answer a question. Would you agree with that?
I think it's a lovely analogy.
Okay, great. Now, I'm not going to wax philosophical because really that's 1.1, just why do we statistics? And so I do love this guy. You might not love him as much as I love him.
Not in the husband sense, but just enjoy what he has to say.
Oh my gosh, yes, for heaven's sakes, yes. So he's a pretty smart guy and he's got some good thoughts. So I'm going to end it with this. When he's done talking, you'll be done with the video. There's not an assignment attached to 1.1. Your first assignment comes with 1.2. Just make sure that you have gotten onto the Google Classroom, the AP Classroom, and then as well the Khan Academy Classroom. Okay? Enjoy.
Back in 2003, the UK government carried out a survey. And it was a survey that measured levels of numeracy in the population, and they were shocked to find out that for every 100 working-age adults in the country, 47 of them lacked level 1 numeracy skills. Now, level 1 numeracy skills, that's low-end GCSE score. It's the ability to deal with fractions, percentages, and decimals. So this figure prompted a lot of hand-wringing in Whitehall. Policies were changed, investments were made, and then they ran the survey again in 2011. So can you guess what happened to this number? It went up to 49. And in fact, when I reported this figure in the FT, one of our readers joked and said, this figure is only shocking to 51% of the population. Well, I preferred, the reaction of a school child who said to me when I presented at a school this information, raised their hand and said, how do we know that the person who made that number isn't one of the 49% either? So, clearly there's a numeracy issue because these are important skills for life, and a lot of the changes that we want to introduce in this century involve us becoming more comfortable with numbers. Now, it's not just an English problem. OECD this year released some figures looking at numeracy in young people, and leading the way, the USA, nearly 40% of young people in the US have low numeracy. Now, England is there too, but so there's 7 countries, 7 OECD countries with figures above 20%. And that is a problem because it doesn't have to be that way. If you look at the far end of this graph, you can see the Netherlands and Korea, they're in single figures. Okay, so there's definitely a numeracy problem that we want to address. Now, as useful as studies like these are, I think they really, we risk herding people inadvertently into one of two categories. That there are two kinds of people: those people that are comfortable with numbers, that can do numbers, and the people who can't. And I suppose what I'm trying to talk about here today is to say that I believe that that is a false dichotomy. It's not an immutable pairing. I think you don't have to have tremendously high levels of numeracy to be inspired by numbers, and that should be the starting point to the journey ahead. And one of the ways in which we can begin that journey, for me, is looking at statistics. Now, I am the first to acknowledge that statistics has got somewhat of an image problem. It's the part of mathematics that even mathematicians don't particularly like, because whereas the rest of maths is all about precision and certainty, statistics is almost the reverse of that. But actually, you know, I was a late convert to the world of statistics myself. If you'd have asked my undergraduate professors what two subjects would I be least likely to excel in after university, they'd have told you statistics and computer programming. And yet here I am about to show you some statistical graphics that I programmed. So what inspired that change in me? What made me think that statistics was actually an interesting thing? It's really because statistics are about us. If you look at the etymology of the word statistics, it's the science of dealing with data about the state or the community that we live in. So statistics are about us as a group, not us as individuals. And I think as social animals, we share this fascination about how we as individuals relate to our groups, to our peers. And statistics in this way are at their most powerful when they surprise us. And there's been some really wonderful surveys carried out recently by Ipsos Mori in the last few years. They did a survey of over 1,000 adults in the UK and said, OK, for every 100 people in England and Wales, how many of them are Muslim? Now, the average answer from this survey, which was supposed to be representative of the broader population, was 24. That's what people thought. British people think 24 out of every 100 people in the country are Muslim. Now, official figures reveal that figure to be about 5. So there's this big variation between what we think, our perception, and the reality as given by statistics. And I think that's interesting. What could possibly be causing that misperception? And I was so thrilled with this study, I started to take questions out in presentations. I was referring to it now. I did a presentation at St. Paul's School for Girls in Hammersmith, and I had an audience rather like this, except it was comprised entirely of sixth form girls. And I said, girls, how many teenage girls do you think the British public think get pregnant every year? And the girls were apoplectic when I said, the British public think that 15 out of every 100 teenage girls get pregnant in the year. And they had every right to be angry, because in fact I'd have to have closer to 200 dots before I could colour one in terms of what the official figures tell us. And rather like numeracy, this is not just an English problem. Ipsos Mori expanded this survey in recent years to go across the world. And so they asked Saudi Arabians, for every 100 adults in your country, how many of them are overweight or obese? And the average answer from the Saudis was just over a quarter. That's what they thought. Just over a quarter of adults are overweight or obese. The official figures show, actually, it's nearer to 3/4. So again, a big variation. And I love this one. They asked it in Japan, they said, they asked the Japanese, for every 100 Japanese people, how many of them live in rural areas? And the average, again, this is the average, was about a 50-50 split, just over halfway. They thought 56 out of every 100 Japanese people lived in rural areas. The official figure is 7. So extraordinary variations, and surprising to some, but not surprising to people who've read the work of Daniel Kahneman, for example, the Nobel-winning economist. Him and his colleague Amos Tversky spent years researching this disjoint between what people perceive and the reality, the fact that people are actually pretty poor intuitive statisticians. And there are many reasons for this. Individual experiences certainly can influence our perceptions, but so too can things like the media reporting things by exception rather than what's normal. Kahneman had a nice way of referring to that. He said we can be blind to the obvious, so we've got the numbers wrong, but we can be blind to our blindness about it, and that has enormous repercussions for decision-making. So at the statistics office, while this was all going on, I thought this is really interesting. I said, you know, this is clearly a global problem, but maybe geography is the issue here. You know, these were questions that were all about how well do you know your country. So in this case, it's, you know, how well do you know 64 million people? Not very well, it turns out. You know, I can't do that. So I had an idea, which was to think about this same sort of approach, but to think about it in a very local sense. Is this a local? If we reframed the questions and say, how well do you know your local area, would your answers be any more accurate? So I devised a quiz. How well do you know your area? It's a simple web app. You put in a postcode, and then it will ask you questions based on census data for your local area. And I was very conscious in designing this that I wanted to make it open to the widest possible range of people, not just the 49% who can get the numbers. I wanted everyone to engage with it. So for the design of the quiz, I was inspired by the isotypes of Otto Neurath from the 1920s and 30s. Now, these are methods for representing numbers using repeating icons. And if you like, the numbers are there, but they sit in the background. So it's a great way of representing quantity without resorting to using terms like percentage, fractions, and ratios. So here's the quiz. The layout of the quiz is you have your repeating icons on the left-hand side there and a map showing you the area we're asking you questions about on the right-hand side. There are 7 questions. Each question, there's a possible answer between 0 and 100. And at the end of the quiz, you get an overall score between 0 and 100. And so because this is TEDx Exeter, I thought we would have a quick look at the quiz for the first few questions of Exeter. And so the first question is, for every 100 people, how many are aged under 16? Now, I don't know Exeter very well at all, so I had a guess at this, but it gives you an idea of how this quiz works. You drag the slider to highlight your icons, and then just click Submit to Answer, and we animate away the difference between your answer and reality. And it turns out I was a pretty terrible guess, 5. How about the next question? This is asking about what the average age is, so the age at which half the population are younger and half the population are older. And I thought 35, that sounds middle-aged to me. Actually, in Exeter, it's incredibly young, and I'd underestimated the impact of the university in this area. The questions get harder as you go through. So this one's now asking about home ownership. For every 100 households, how many are owned with a mortgage or loan? And I hedged my bets here because I didn't want to be more than 50 out on the answer. And actually, these get harder, these questions, because when you're in an area, when you're in a community, things like age, it's pretty, you know, there are clues to whether a population's old or young. Just by looking around the area, you can see it. Something like home ownership is much more difficult to see, and so we revert to our own heuristics, our own biases about how many people we think own their own homes. Now, the truth is, when we published this quiz, the census data that it's based on was already a few years old. We've had online applications that allow you to put in a postcode and get statistics back for years. So in some senses, this was all a little bit old and not necessarily new, but I was interested to see what reaction we might get by gamifying the data in the way that we have, by using animation and playing on the fact that people have their own preconceptions. It turns out the reaction was more than I could have hoped for. It was a long-held ambition of mine to bring down a statistics website due to public demand. This URL contains the words statistics, gov, and UK, which is 3 of people's least favorite words in a URL. And the amazing thing about this was that the website came down at 9:45 at night, because people were actually engaging with this data of their own free will, using their own personal time. I was very interested to see that we got something like 250,000 people playing the quiz within the space of 48 hours of launching it. And it sparked an enormous discussion online on social media, which was largely dominated by people having fun with their misconceptions, which is something that, you know, I couldn't have hoped for any better in some respects. I also like the fact that people started sending it to politicians. How well do you know the area you claim to represent? And then just to finish, going back to the 2 kinds of people, I thought it would be really interesting to see how people who are good with numbers would do on this quiz. The National Statistician of England and Wales, John Pullinger, you would expect he would be pretty good. He got 44 for his own area. Jeremy Paxman, admittedly after a glass of wine, 36. Even worse, okay? It just shows you that the numbers can inspire us all, they can surprise us all. So very often we talk about statistics as being the science of uncertainty. My parting thought for today is actually statistics is the science of us, and that's why we should be fascinated by numbers. Thank you very much.